Okay, so today we are covering Module 5, Lesson 31, and our objective is that we want to be able to multiply a fraction by a whole number using decomposition and visual models. So, let's get started. We have the first problem we're going to do is we're going to multiply a whole number times unit fraction. But before we really get into this, let's go over some basics here. If I have 6 times 2, I've written a mathematical expression or equation, and I've written a multiplication sentence, right? Well, let's say I want to turn this into a repeated addition sentence. So another way to write this is 2 plus 2 plus 2 plus 2 plus 2 plus 2. Or you could write it 6 plus 6. Either way. But we're really not going to look at this one. We're going to look at this one. All right. So 6 times 2. That's the the multiplication sentence, and then we have our repeated addition sentence. Well, another way to visualize this would be show this on a number line. So if I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so if I show this, we've got 1, 2, 3, 4, 5, 6 2's, right? And we know this because it is 6 times 2. So 6 2's. So we're going to look at we're going to look at the 6 jumps and find our answer. So we jump 1, 2, then we jump our second 2, then we jump our third 2, fourth 2, fifth 2, and sixth 2. So this, you can see here we have 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps, and our answer ends up being 12. So 6 times 2 equals 12, which also equals 2 plus 2 plus 2 plus 2 plus 2 plus 2, which also equals 6 plus 6. So you see here I have written a multiplication sentence, I've written the answer, I've written the repeated addition sentence, and I've written another repeated addition sentence. So you see that there are a lot of ways to represent 12. As a mathematical expression, 6 times 2, just writing 12, breaking it up into a repeated addition of 2 plus 2 plus 2 plus 2 plus 2 plus 2, or another repeated addition of 6 plus 6. So there's a bunch of different ways to write it, but these 4 different ways of representing it, they all mean the exact same thing, right? Well, let's get started looking at how this works with fractions. So or instead of doing 6 times 2, now I'm going to do 6 times 1 half. Okay? So another way you could write this is as a repeated addition sentence. Or we have 1 half plus 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 1 half. Right? So there are 6 1 halves. Now we can represent this on a number line. But before we do that, I'm just going to put equals, and we're going to put 6, because we just said it. We said 6 1 halves, right? So if you add this up, 1, 2, 3, 4, 5, 6, there are 6 1 halves. Now I'm going to go ahead and number my number lines. This is 1 or 0 out of 2. That's 1 out of 2. That's 2 out of 2 is 3 out of 2, 4 out of 2, 5 out of 2, 6 out of 2, 7 out of 2, 8 out of 2, 9 out of 2, 10 out of 2, 11 out of 2, 12 out of 2, and 13 out of 2. Now, we're starting at 0 and we're going to count 1 halves, and we have 6 of them. So I'm going to count 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So we ended up at 6 halves. And you can see here we have 1, 2, 3, 4, 5, 6. So we have 6 1 halves, right? And we ended up at 6 halves. So you can see these three expressions mean the exact same thing. Well, let's break it down a little bit further. So taking a look at this repeated addition here. If I were to put a bracket around this, like so, we know that 1 half plus 1 half really equals what? 1 whole, right? Because 1 half and another half, if you put them together, make 1 whole. So what if I rewrite this like this? I have 1 half plus 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 1 half. Alright, and look at this like this, right? We break them apart with parentheses, like so, right? So, this we know is still equal to 6, 6 times 1 half, right? Well, we really have how many groups of sorry, I want to make sure I say this correctly. If we have 1 half plus 1 half, we get 1 whole, right? Well, we can represent that whole as either 2 over 2 or 1, right? So let's look at this for just a second. If we represent this as 2 over 2, then let's take a look. This 1 half, we have this grouping right here of 2 over 2. How many of these groupings do we have? We have 1 grouping, 2 grouping, 3 grouping. So we could really write this as 3 groupings of 2 over 2, right? Because we have 1, 2, 3 groupings of 2 over 2. And we know that because 1 half plus 1 half equals 2 halves. So we can put that together so that these things all mean the same thing. Alright, but we can go even a little bit further because I said we can represent this as 2 halves or as 1 whole, right? So we could write this as we have 3 groupings, 1, 2, 3, of 1 whole, right? And so we have 3 times 1. Well, we know what 3 times 1 is. What is 3 times 1? 3, right? So again, we can represent this as 6 times 1 half as a repeated addition statement. We can express this as an improper fraction. We can express this as a mixed number fraction, but or just as a whole in this case. We can represent this as a different multiplications expressions. So there's a bunch of different ways to represent all of the same thing. We can show it with a visual model here on the number line, and again through our different mathematical expressions. So you can see here there are a ton of ways to represent this. All right, so let's move on to problem 2. All right, now we're going to take the same problem we just did, but we're going to do the exact same thing, exact same problem using the same numbers, but this time we're using the associative property and not just working it out like we did before. So right now we have 6 times 1 half, and we know that this equals 6 halves, right? So this equals 6 halves. Well, I'm just going to rewrite this as unit form. So I'm going to put 6 halves. Put it into unit form. All right, now we've got a number line here, and I just really want to go ahead and number it. So we have 1, 2 and 3 wholes. And as we know, 6 halves, when we make those jumps, we can sort of count. Oops. Oh, no. Come back. Alright, sorry. My computer was trying to be funny. Alright, we know that this is really, we can represent it as a jump like this. And we're going to show you how to do that. Because we know our answer is 3, right? Because we know the 6 halves from the previous page. So we're going to show, I'm going to kind of work backwards now and show you how we got there. So we have 6 halves. Now it's written in unit form like this, right? And if you remember when we did the associative property, we have to break up a number into its factors, and then we're going to reassociate them to see if we get the same answer. So 6 halves. I'm going to break this 6 up. Now, what are 2 factors of 6? Well, you could say 2 times 3, right? Or 3 times 2. You could also say 6 times 1, but in this case, we're going to do 3 times 2. All right, because if you'll notice here, we're trying to associate that we have 3 jumps of the halves, right? So we have 3 times 2 halves. All right. Now, I'm going to reassociate this. Instead of breaking apart this 6 and leaving this halves alone, I'm now going to reassociate this 2 with the halves. So I have 3 times 2 halves. And if you'll notice, another way that we wrote this on the page before was we just did 3 times 2 halves. So that's basically what I just wrote. I just wrote it a little differently. So you can see here, I wrote this 6 times half, right? So we have 6 halves. Now all I did was I just broke this up 3 times 2. Broke that 6 up into 3 times 2. So now I've reassociated the 2 times the halves. So it looks, another way to write this is like that, right? All right. Now we know that I'm going to actually, you know what? I'm going to go ahead and write it like that. I'm going to go ahead and put 3 times 2 over 2, like that. Okay, now we know that 2 halves is really equal to 1. So I'm going to rewrite that because this is going to become 3 times 1 whole. And then we know that 3 times 1 gives us 3. And if you look here, when we did 3 times 2 halves, we ended up with 3, right? So we can say that 6 halves equals 3. Or another way to write it would be 6 times 1 half equals 3. All of these things mean the same thing. So you can see here we use the associative property to break up the 6 into its factors, reassociate the 2 with the halves, and then rewrite that so that it's more clear as 2 halves in fractional form. And then we multiplied it when we had changed 2 halves to 1 whole, and then we got our final answer. So I know you guys struggled with the associative property. Excuse me. Struggled with the associative property when we did it back in module 3, but hopefully this is making it a little bit easier since we've done it before. But if you still have questions or if this is still a problem, then let Mrs. Simone and I know, and we will be happy to help you out with that. Okay, so now problem 3. You should get a pencil and paper for this. We are just going to be expressing the product of a whole number times a unit fraction as a mixed number. So it's really easy, but I want you to do it along with me. So get a pencil and piece of paper and hit continue when you're ready. All right. So the problem we're doing now is 9 times 1/4. So we have 9 times 1/4. So how many fourths make up one whole? Well, we know that there are 4, right? So how many groups of 4/4 are in 9/4? Because we have 9 times 1/4, right? Well, we know that there are, if we were to look at this, is a number bond. We have 9/4, right? Because if we have 9/4, then we have 9/4 here. And we're going to break this up into 4/4, so one whole. And then how many groups of this 4/4 can we get? Well, if I do 9 minus 4, I end up with 5. So I can do one more group of 4/4. Well, 4/4 plus 4/4 equals 8/4, which means on 9 minus 8, I still have 1/4 left, right? So, 2 groups of 4/4 make 8/4 with 1/4 left over. Now, what I want you to do is I want you to, I'm going to fill this out, this number line, just like this. And I want you to draw a number bond or a number line that represents this number bond. Okay? So go ahead and draw that on your number line. All right, hopefully you drew something like this, because you know that 4/4 equals, you know that 4/4 equals one whole. And then we have another 4, oh my goodness, guys, 4/4 that equals one whole. But then we have this 1/4 left over, right? So I'm going to go ahead and put a little dot here. So this is 1/4. And this was 4/4 and 4/4. So this point equals 9/4, right? So hopefully you did something like that. Now, let's talk about how we can write this, showing the way we've been renaming things and showing you the different ways to write it. So we start off with 9 times 1/4, which equals, what we said over here was we have 2 groups of 4/4, right? So we have 2 times 4/4, right? And then we have to add in that little extra 1/4. Now we're going to change this, because if we have 2 groups of 4/4, we know that's really one whole. So 2 times 1, well, that just equals 2. So then we can write this as 2 and 1/4. Well, now we can just rewrite this as our mixed number fraction. So you can see here that 9 times 1/4, we can just write this as a mixed number fraction as 2 and 1/4. And we see this on the number line because we have 2 wholes and 1/4. So 2 and 1/4 is the answer. All right. That's it for today. So it's not very difficult. This is more of a conceptual lesson than procedural lesson. So I know Mrs. Simone and I have discussed with you before that when we do a lot of procedures, sometimes it's not very complicated, but when we do the conceptual lessons that deal with like the associative property and that really go make you have like a big idea picture, make sure you understand what the numbers are doing. Not like, here's the procedure, this is how you multiply, this is how you add, but like this is what is happening to the numbers. This can be a little bit more difficult, and it's really one of those lessons you have to like sort of sit back and think about to understand. So we know that this is one of these lessons, so it's not difficult. We didn't do any new procedures. Nothing is new in this lesson. We're literally just scaling back for a second and looking at the big idea here. So if you have any issues understanding the big idea and what's happening to these numbers and why we're doing certain things, then make sure you talk to Mrs. Simone and I. And again, we're always available on Zoom, chatting on Google Classroom, Class Dojo, texting, phone calls, you name it, we're there for you. So make sure you take advantage of that. And good luck. Have a good rest of your day. All right. Talk to you later.